Hi, Algebra 2 students. Lesson 4.5 today, section 4.5, which now talks about, we're going from, we talked about all the different equations, vertex form, standard form, intercept form. We've been factoring kind of the whole way with warm-ups. And now we're going to take a look at solving quadratic equations by factoring, okay, and graphing them by factoring and things along those lines. But pretty much everything that relates to factoring a quadratic. So if we take a look, step number one, and this is the reason why we started with this in the warm-ups, is the first thing you should always look for is a greatest common factor, okay, to see if you can factor anything out that will then make everything else easier after that. So that's step number one always. Step number two then is if there are two terms, okay, then you want to think of a difference of squares and see if you can factor your difference of squares. If there are three terms, then you want to think of like your general trinomial factoring, where you put down the two sets of parentheses and you start figuring out what combination works to get the right set of factors. Okay, so that's kind of your general trinomial. If nothing else works, then the expression is prime and cannot be factored. Okay? Now, one point I want to make right away is that does not mean that it cannot be solved. Okay? We could end up using what's the quadratic formula, if you remember, and that's kind of what's coming eventually. It just means it cannot be factored. Okay? It is still solvable for the most part, but we don't have that method yet that we've talked about. So we're just working on factoring. And so there's kind of your process as you work your way through. Look for a greatest common factor, then look to see whether you've got two or three terms. Try to factor it as either a difference of squares or just a general trinomial. And if nothing works, it is possible that it could not be factorable and therefore is prime. Okay? So a quadratic function, once again, y equals ax squared plus bx plus c, that's standard form. This is what we talked about as a function with two variables. Okay, so we've talked about standard form before. A quadratic equation is one where it now equals 0. Okay? And so this is where we're headed before. So the first part of this has all been, here's a quadratic function, and we've been looking at the graph and all that kind of stuff. Now we're going to set it equal, and we're going to find the x-intercepts, okay, when y equals 0. Sometimes called the x-intercepts. You might hear them referred to as zeros because we're plugging in 0. You might refer to them as solutions. You might hear roots as another one. So those are all kind of the same basic idea. Okay, so just keep that in mind as you're working through this. So on the graph, what does it mean when you use 0 as your y value? We just talked about that. That means those are your x-intercepts. That's what we're looking for. When y equals 0, you found your x-intercepts. Okay, so that's the general idea. That's where we're going. We're going to now start to talk about how do I find my x-intercepts if it's possible. Okay, and so far we're talking about finding the x-intercepts by factoring. So here's exactly what we just said. You have three different situations for x-intercepts. Okay, so as we go through and we take a look, the options are, okay, and let me put this together here, and then there's graphical representations of each as well. So option number one, the first thing that could happen is you could have two x-intercepts. Hang on, let me get rid of that. Clean that up a little bit. It's possible to have two x-intercepts. For example, that would be a graph that kind of looks like this, or it could be opening down too. It doesn't really matter, but where it crosses the x-axis in two specific spots. Okay, that's the first thing that could happen. The second thing is you might only have one x-intercept. Okay. And so you might ask, well, how is that going to happen? Well, and again, it could be opening up or it could be opening down. This time I'll have it opening down. You could go through and it could just touch and then come back down. And therefore, your only x-intercept is the vertex. Okay? The vertex of your parabola just might also be the only x-intercept that you have. Okay? And then the third option is that you could have 0 x-intercepts. You might not have an x-intercept. What would that look like? That would look like a graph that either opens up and is entirely above the x-axis, meaning it does not cross, Or you might have one that opens down, but is also entirely below the x-axis. So those would be two different scenarios where you would have no x-intercepts. And like we talked about earlier in the lesson here, that if you were trying to factor that, these would definitely be ones that were prime that would be not factorable, okay? So those are the three things that could happen when we're talking about x-intercepts and graphing and what that all means as we put everything together, the equation with the graph, okay? All right, as we keep going then, so in order to solve a quadratic equation then, we are going to use the zero product property. We talked about this previously. The zero product property, or ZPP, refers to that if A and B are factors, okay, and one of these two factors, when you multiply them together, equals 0, that means one of the factors had to equal 0, or both of them, okay? Either the first one or the second one had to equal 0. Because when you multiply by 0, that means you get an answer of 0. So, here's a scenario, if this was my problem and we set these factors equal to 0, let's say we factored our problem, we got it to this part. Now what I'm checking when it says what do we set equal to 0 here, we set each factor. So if x minus 2 equals 0, that means you'd take 0 times the x plus 4 and you would get 0. Okay? Or x plus 4 could equal 0. Therefore, the first one you add the 2 over, x equals 2 would be your solution. Over here, subtract the 4, x equals negative 4 would be your solution. Okay? So if this was your problem, here would be your two x-intercepts in this case. X equals 2 and x equals negative 4. You always just take each factor and set each factor equal to 0. So if we solved, we just did that. Okay? And so now, if the graph, this is just intercept form is all this is, okay? So factored form is the same thing as intercept form. So if I was going to graph that, we had said x equals 2, x equals negative 4. Those are the two x coordinates, the x-intercepts. A value here is 1 in intercept form or standard form, okay? So we know it's opening up. We know that the vertex would be halfway between these 2 points, okay, and so on and so forth. And now we revert right back to everything else that we've already talked about, is the idea. So let's say we go through and let's just do some solving here first off. Let's say we want to solve by factoring. So in this case, first thing we look for is a greatest common factor. Well, if you notice, there's not an x in all three of these, nor is there a numeric common factor that I can take out of everything. So in this case, we are going to factor this just as a general trinomial and see what we can come up with. First place, remember we always write down what multiplies to give you the first term. So that's x times x. And then, because I have a 1 for an x squared, what I'm looking for is what numbers are factors of 32, what multiplies to give me a positive 32 that would add to give you a negative 12. And in this case, we would end up with x minus 8 and x minus 4. Negative 8 times negative 4 is a positive 32. Negative 8 plus a negative 4 is a negative 12. Okay? And so that's what's going on as we work our way through that. Now if I go through and I solve, that means I take my first factor, set it equal to 0. Take my second factor, set it equal to 0. And therefore x would equal 8. And x would equal positive 4. Therefore, those are your two x-intercepts that you have in this problem. Those would be your solutions. Okay. In problem number 2, since this does not equal 0, we have to get it equal to 0 first. Therefore, 25x squared minus 16 equals 0. Now I can go through and try to factor. Again, I do not have any common factors, therefore I can't take anything out. So in this case, notice I do have two terms, so I'm going to factor this as a difference of squares. So if I go through and I put my parentheses down and I set it equal to 0, first thing that's being squared here is what we're looking for. We are squaring 5x. Therefore, 5x is what goes in the first spot. In the second portion then, what are we squaring to get 16? We are squaring 4 in each one, so that goes in the second spot. And in order for us to get a middle term of 0, then I am always going to have a plus and a minus sign. So now I would go through and set my factors equal to 0. 5x plus 4 equals 0. 5x minus 4 equals 0. Subtract the 4 and then divide by 5. This one I would get negative 4/5 as my answer. And then over here I would add 4 and divide by 5 and get a positive 4/5 as my answer. So there would be my two solutions in that one. Okay. If we keep going, let's do one more together here. This last one, same kind of idea, but now we have to go through, and let me move this down just a little bit. But now we have to go through and, again, get it equal to 0 is step number 1. And then from there we can factor. So I'm going to subtract over that x squared. I'm going to subtract over the 2x. And I'm going to add the 5. Those will all cancel out. Here I'm going to end up with 2x squared minus 3x minus 35 equal to 0. Now we take a look for a greatest common factor. Once again, there's nothing there. So we factor this as a general trinomial. Okay. What multiplies to give me the 2x squared? 2x times x. And now we have to go through and try to find the right combination here to get 35. So 7 and 5 is probably the right combination. You got to figure out where will they go. Okay, I'm going to do this one correctly on the first try here. So in this case, I'm going to put the 7 here and the 5 there. Remember, whenever you've got a number in front that's not 1, you got to check the inside and the outside terms. Okay, so this ends up, I would multiply, would give me 7x. The outside would give me a 10x when I multiply. I need a negative 3 as my middle term when I put those outside and inside together, which means the 10 is going to have to be negative and the 7 is going to have to be positive. Therefore, this is a plus sign, that's a minus sign. So there's your factored form, and now I use my zero product property to solve. We set 2x plus 7 equal to 0. We set x minus 5. Let me get rid of that. We set x minus 5 equal to 0. First one here, we subtract the 7 and then divide by 2. So x would equal a negative 7/2. Second solution then, we add the 5, and x equals 5. Okay? So we are in good shape for that. So there's kind of each idea here. This one was a general trinomial that we could factor and solve. Second one was a difference of squares that we had to get equal to 0 first, then factor and solve. And then last one ended up being a general trinomial, but now with a leading coefficient that was not 1. Okay? So just an example of all the different methods of solving. So now if we take that one step further here, and we go through and we now graph these, okay? As we work our way through this, now it makes things a lot easier to put this in factored form. Okay? And we already did all of these, so this was your first one right here that we ended up finding. First thing we could write down, I'm going to put down the x-intercepts. We found those. If I go back, that was 8 and 4 by factoring. So I know that I've got x-intercepts of 4 and 8, which means my vertex then, I know is going to be halfway between those values. So I know I've got an x-coordinate of 6. And now I got to plug that back in order to get the y-coordinate. So 6 squared minus 12 times 6 plus 32 gives me an answer of negative 4 for my y-coordinate of my vertex. Okay? I know the a value in this case is 1. It's in front of the x squared. That tells me that this is opening up. I can put in here the axis of symmetry is going to be x equals 6. It's going to go right through the middle of the vertex. And then the only thing left is to find the y-intercept, which you can always, because this is in standard form, your y-intercept in this case is, whoops, let me get rid of that. your y-intercept in this case is 32, okay, which obviously is not going to be on this graph, but that's okay. So if we plot our x-intercepts, 1, 2, 3, 4, and 8, we said our vertex is halfway between, and then down 4 is what we found. There's my vertex right there. Oop, nope, that's 3. I got to put down one more. There's my vertex. The y-intercept would be way, way, way up here, so I'm not going to worry too much about that. If it was on the graph, I would plot it, but otherwise, a value of 1. Oops, that's not real great, but you get the idea at least. And there's what your parabola looks like. Okay, so there's one way of factoring and then going through and solving. Okay, here's the same idea. In this case, if you factored, I'm not going to worry about going through the rest of this because it's the same idea as what we just did. But 25x squared minus 16, it's the exact same problem that we had here. You found your x-intercepts. Okay, they're not the nicest ones in the world, but we can work our way through that. And then same thing in problem number 3, 2x squared minus 3x minus 35. The main thing I want you to get out of that is that's what we ended up with when we got this equal to 0. So once again, you already have your x-intercepts. What I would like you to do, though, I'm not going to go through them on the video, but I would like you to go through and try those. Okay, find the x-intercepts, the vertex, the axis of symmetry, work through that, and actually do these 2 problems. Shouldn't take too long, should be fairly quick. And then if you have any questions when we get back to class, I want you to bring those questions with you to class and we will go over them if we need to. Okay? Last one here is, and I'm not even going to worry about this one, I don't think. I'm going to skip through that one. So the practice to learn that goes with this would be your 4-5 worksheet. Again, I want you to take a look at the factoring that would go with the graphing and the x-intercepts and all that kind of stuff. Good luck on everything, and bring, like I said, any questions from the lesson or the worksheet with you to class, and we will go over those the next time I see you. Good luck, everybody.